Hello and welcome. In this video we're going to take a look at Amazon Web Services SageMaker. SageMaker is a fully managed machine learning service that allows data scientists and developers to quickly and easily build and train machine learning models and then directly deploy them in a production-ready hosted environment. And the documentation is pretty good, which should get us up and running fairly quickly. In this video, I'm going to walk through the Getting Started tutorial of creating a dataset, training a machine learning model, and then deploying that model to a production environment. Once we know we have SageMaker working correctly, then in another video, we'll deploy one of our own custom models. So let's get started. To use SageMaker, you need an Amazon Web Services account. If you don't have an AWS account, signing up for one is easy. Just go to aws.amazon.com, and in the upper right hand corner there will be a button that says Create an AWS account. I already have an AWS account, so mine says Sign into the console, but if you don't have one, it'll say Create an AWS account. So click on it and fill out your information. Once you have an account, log in and you'll be taken to the AWS Services Console. To walk through the SageMaker tutorial, you need an S3 bucket. If you don't have an S3 bucket, you need to create one. From the AWS console, click on S3, then click Create Bucket. Enter a bucket name that includes the word SageMaker and click Next. On the Configure Options screen, leave everything set to default and click Next. On the Set Permissions screen, leave everything set to default and again click Next. And on the Review screen, click Create Bucket. Your bucket will be created and appear in the bucket list. Now we are ready to create a SageMaker notebook. The cost of running a SageMaker notebook instance for model building is 4.64 cents per hour in the US East region. Check your region's cost before proceeding. From the AWS console, click on Amazon SageMaker. Then click Create Notebook Instance. Enter a name for the notebook instance. Leave the instance type set to ml.t2.medium and select Create New IAM Role for IAM role. Here we're going to enter the bucket name we created earlier and then click Create Role. To allow the notebook internet access, which we'll need for this demo, select the default virtual private cloud under VPC. And select the subnet under subnet. Then select the default security group. Then click Create Notebook Instance. After a few minutes, status should change from pending to in service. To begin, we need to click Open to start an instance of a Jupyter notebook. Then click New and select conda_python 3. This will start a new notebook. Click on the name Undefined and give your notebook a name and click Rename. If you go back to the Jupyter Notebook home, you should now see your new notebook's name. We are now ready to develop our first model. The demo uses the MNIST dataset. The MNIST dataset consists of 60,000 examples of handwritten single-digit number images and a test dataset of 10,000 images. We will use the k-means algorithm included in SageMaker to group the numbers into 10 clusters, one for each number. Amazon recommends using the high-level Python library provided by SageMaker for training, deployment, and validation. First, we must get the execution role for the bucket. Replace the SageMaker-your bucket with the bucket name you created earlier, then run this code. Then we'll take a look at the role to make sure there's no error. Okay, now we want to download the MNIST dataset. Once the file is downloaded, we can look at some images. The image in the 31st location is the digit 3. And the image in the second location is the digit 0. Note that when we imported the data, we also created a train set, a validation set, and a test set. These are NumPy arrays. Amazon recommends converting the data to the record IO protobuf format. Since we are using the high-level Python library, the fit function will transform the data for us and upload it to our S3 bucket before starting a model training job. So SageMaker will handle converting the data to the record IO protobuf format for us. Now that we have our data, we first have to create an instance of the SageMaker k-means class. Then we can train our model. Amazon's documentation states that training will take about 15 minutes on this demo using an ml.c4.8x large instance, which costs about $2.23 per hour. So 15 minutes should cost us about 56 cents. However, when I ran this training, the training was complete in far less time. So that took a little over 3 minutes, and the billable seconds is 155, which is about 2.5 minutes of actual billable time. So that's really not too bad. Now that we have our model, we can deploy the model to make predictions. It takes about 5 minutes for the deploy function to complete. The cost while the model is deployed on an ml-m4.x large instance is 28 cents per hour. So it's something to keep in mind, because while the model is actually deployed, you're billed the 28 cents per hour for this instance. So when we complete the demo, we're going to clean up and delete this instance that's being created now. So that took just over 5 minutes. Once the model deployment is complete, we can then validate the model and send sample requests and get inferences. So let's submit the first 100 images from the validation set and see how SageMaker groups these images. Note that each group does not correspond to the image value. In other words, the k-means algorithm may not assign images of zeros to the first group and images of ones to the second group. We can print the images in each group, and note that the algorithm did not do a very good job at classifying these images. You know, we have 5s and 8s and 3s all clustered together, 4s, 9s, and 7s. You know, the 6s all look pretty good. You know, there should be higher accuracy between a 3 and a 1. Since in the model definition no epoch value was specified, the training was run for only one epoch by default. Let's modify this to 100. And now we'll rerun the fit command. Okay, so that took just under 4 minutes. Now that we have a new model, we can create another endpoint. Okay, so that took a little bit more than 5 minutes. Now that we have a new endpoint, we can resubmit the 100 images and see how well training under 100 epochs performs. So this time, you know, we have more similar images grouped together. Got all the zeros correct. All the 6s look pretty good. The 1s look much better. So overall, as we would expect, training for 100 epochs improves the performance. It's not as good as a TensorFlow model that I've developed in the past, but remember, this is a k-means algorithm that we only trained for 100 epochs. Now that we have an endpoint, let's submit one image and see what the predicted value is. Let's submit the image at location 230 of the validation set. The model predicts this is an image in group 9, which is most likely the image of the digit 2, and indeed the image is the number 2. So that's it. We configured a k-means model, trained it, deployed it, and ran some inferences on it. So not to incur any further charges, we need to delete the resources we are consuming. First, click kernel and then shut down. From the SageMaker console, click the notebook instance and click Stop. Click on Training Jobs and delete all the training jobs. Click Models and select all the models and delete them. Select Endpoint Configurations and delete all the configurations. If you do not delete the endpoints, they will continue to run and you will be charged. So select endpoints and delete all the endpoints. Also, delete the S3 bucket, IAM role, and log groups, starting with the /AWS/SageMaker in the CloudWatch console.
So there you have it. SageMaker makes developing a machine learning model, training it, and deploying it easy. I hope you found this video useful. If you did, please subscribe, and if you think this video might be helpful to someone else, please share. Also, the code is available at the GitHub link below. If you have any questions, post them below and I'll try to answer them. And also, if there are any topics you'd like to see a video on, post that also in the comments below, and thanks for watching.